Today's homework help video is for Chapter 3, Lesson 1, Constant Rate of Change. The assignment was page 175, number 1, 3, 4, and 6. So for today's assignment, we need to determine whether the relationship between the two quantities shown in each table or graph is linear. If so, find the constant rate of change. If not, explain your reasoning. So to calculate this, I look at my change in time, which is the x variable. So 5 to 8 is 3, 8 to 12 is 4, 12 to 24 is 12. And then I look at my change in cost. 15 to 24 is 9, 24 to 36 is 12, and 36 to 72 is 36. Now, even though these increments aren't going up evenly at this point, I can still determine if the rate of change is constant by looking at the change from 15 to 24, which is 9, over the change from 5 to 8, which is 3. So I can write that as a ratio. Remember, change in y over change in x. So I've got 9 over 3, which equals 3 over 1 if I reduce it or simplify it. And then I've got 12 over 4, which also equals 3 over 1. If I simplify, 12 divided by 4 equals 3, and 4 divided by 4 equals 1. And then I also have 36 over 12, which I can simplify by dividing 36 by 12 to get 3, and 12 by 12 to get 1. So since the ratio is the same for each of these situations, again, the change in y, which is the cost, over the change in x, which is the time, all the ratios are the same, all the ratios are 3 over 1, so this is a linear relationship. So that was a really good example to show, we don't always have to go up by, consistently equal amounts to have a linear relationship. So let's look at number 3. Now we've got a ratio of oil to vinegar. So we've got change from 2 to 4, which is 2, 4 to 6, which is 2, 6 to 8, which is 2. And then we've got some fractions we're gonna have to deal with here. So 3/4 to 1.5 is 3/4. 1.5 to 2 1/4 is 3/4. And 2 1/4 to 3 is another increase of 3/4. So in this case, we've got a change in y of 3/4 over a change in x of 2. So essentially what we're looking at is 3/4 divided by 2, which is 3/4 divided by 2 over 1, equals, remember you flip the last fraction and multiply. So we get 3/4 times 1 over 2, which is 3/8. So in each of these cases, we've got a change of 3/4 over 2, and that change is actually 3/8. So the answer to this question is yes, it's linear. Let's take a look at problem 4. So in this case, we're looking at a graph, and it'll be much easier to determine if this is a linear relationship by looking at the values in a table. So let's look at time. This is our x variable. And then I'm going to abbreviate water level. And that's our y variable. So first, we are at 0, 0 for time and water level. And then I have increments of 2, so this would be 1 and 2. So at a time of 1, the water level is 2. At a time of 2, the water level is 4. And at a time of 3, the water level is 6. So you can already see the pattern. 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1, 0 to 2 is 2, 2 to 4 is 2, 4 to 6 is 2. So in each of these cases, we've got 2 over 1. So the answer to that question is yes, that is a linear relationship. And the rate of change is 2 over 1, or 2. And then finally, let's look at number 6. We've got number of people on our x-axis. And then we've got total cost on our y-axis. So we read our graph. At 5, total cost is 100. At 10, total cost is, we go 100, 150, 200, this would be 175. So I said 10 would be 175. And then at 15, we're at 250. So we look at our rate of change here. From 5 to 10 is 5, 10 to 15 is 5, 100 to 175 is 75, and 175 to 250 is 75. So we've got a change of 75 over 5 in each of these cases. To find the unit rate, we take 75 divided by 5 and we get 15. So the rate of change is actually 15. And that would make this a linear relationship. So I hope this helps. Again, if you have any questions, please feel free to reach out at the end of class or check in with me any day during MLT.